Hello and welcome to episode 141 of our SAP on Azure Video Podcast. Today is April 27th, and together with Robert and Goran, we're here to talk about anything related to SAP and Microsoft. Hello, everyone.
Hi.
So single points of failures are always a pain. That was actually one of my focus areas when I started at SAP almost 20 years ago and focusing on the SAP Enterprise Portal, making sure that we remove all these single point of failures using high availability clusters and stuff like that. Now, looking at SAP, we still have several of these single points of failures. So HA, high availability, is still relevant. And today, we are very lucky to have Ralitza joining us again, who will give us an update on the latest with HA for SAP on Azure. But before we go hand over to her, let's, as always, quickly take a look at some of the news from this week. And I want to start with a blog post, with yet another blog post from Martin Pankratz about Private Link. I actually, he hasn't numbered them, but I don't know, maybe this is the 10th or 15th blog post on Private Link. So we really see a lot of customers looking into Private Link, using this to connect their business technology platform running on Azure to their SAP systems running on Azure. And now in this blog post, he talks about how you can use Private Link if your backend system doesn't use OData services, where you can have a proxy basically in between that does all the translations. And like always, Martin guides us through the whole setup, really starting from scratch, how to get started, how to set up the individual pieces to get it working. And it's a beautiful blog post that really guides you through the steps on how to use Private Link also in scenarios where you don't have the OData services and where you need to have this translation in place. So definitely something to check out. Then, Robert, you reminded me on the blog post from Mark, who published some time ago, back in February, a blog post on DNS integration with SAP RISE. So we had talked about that actually briefly back then, but now Konstantin Popov has updated actually his white paper. So some time ago, he had published a quite extensive white paper on DNS integration, and now he updated the whole white paper. It's a pretty long and extensive, 19 pages document that really outlines the different settings and configurations and things to consider when using a DNS with SAP on Azure. So it's definitely something that you should check out when starting your configuration journey, or also doing updates in your environment and looking at DNS integration. The next thing is the recap conference and the UI5 conference that will happen on July 5th and 7th. So actually, I mean, as mentioned, we are recording this on the 27th. So the registration process is now open, but looking at the registrations from last time, this will probably be sold out in the next few hours. So I unfortunately have to tell you that most likely there are no spaces left. What I want to highlight is that on Wednesday, and maybe there are some spaces left for the Wednesday hackathon, we have a hackathon to enable Azure Cosmos DB with CAP. So that potentially when you develop a CAP, a cloud application programming application from SAP, you can also use Cosmos DB as a backing database. So if this is not yet sold out, and if you are interested in Cosmos DB and CAP, then maybe you can sign up here as well. But with this, I actually want to switch to something that we typically not cover, and these are the quarterly numbers that we released. And I will certainly not go over the details there that were released, but I do want to highlight a few things that I found really, really impressive. So Teams has now over 300 million monthly active users, which I think is amazing. And there are thousands of paid customers now for intelligent apps and stuff like that. And actually this whole AI topic is kicking off like crazy. So in the call They talked about 2,500 Azure OpenAI services customers that are using this. And also, what I also found interesting, GitHub Copilot for GitHub Copilot for Business, where you actually pay for benefiting from the Copilot, has over 10,000 organizations signed up. So you can really see that customers see this value add in leveraging AI technologies in their business and also in their development scenarios. And actually, another customer where we can see this is if we head over to SAP. So SAP also just released their quarterly numbers last Friday, and the numbers were also very good, and you could also see the share price was increasing quite a bit, so that was also good. But what was also interesting, if you listened to Christian Klein, Christian Klein clearly outlined that he is working very closely with us, so with Microsoft. They are doing a lot of investment in Azure OpenAI, and I mean, who knows? Maybe the stock prices rose so much because of this strong collaboration that we are having with SAP. So
Holger, I believe it's still SAP on Azure YouTube channel. Was the
okay, that's the other point. Yes, of course. Thanks, Cora.
Sorry, please.
It's just because of that. That makes total sense. Yes. But no, I mean, he was talking about over 50 AI use cases that they are already implementing, and obviously he didn't share any details, but Sapphire is just around the corner, so that's where we'll probably see a lot of interesting scenarios. And actually, that is Sapphire is also, I mean, it is on site in Orlando, but there will be also a virtual event. There will also be on-demand sessions. So whether you are in Orlando, then come by the Microsoft booth. I think we'll also have some really cool sessions there. But if you cannot make it, then definitely join this virtually and participate. One last thing before we hand over to Ralitza is with this whole OpenAI or Azure OpenAI hype or interest with customers. Microsoft IT basically, or I know it's not called Microsoft IT, but the teams behind that basically, they have released an Microsoft AI SDK for SAP. So basically this allows an ABAP developer to simply consume and leverage Azure OpenAI services. So the idea is if you are developing an ABAP report or doing some development on the ABAP stack, that you can very easily consume Azure services. And when I had some discussions earlier today with Martin Pankratz, who created this blog post on Private Link, we thought about, look, there's so much going on with this prompt engineering at the moment. So maybe it would be nice to have some SAP related prompt engineering. And here I am in the Azure OpenAI studio. So I'm here in the chat playground. And we thought let's start with an easy prompt and just ask a simple question about some relevant BAPIs. So Martin and Sebastian Ulrich, they joined us last time where they showed up how to lock users from a logic app with Microsoft Sentinel. So if there's some suspicious activities in the SAP system, we can detect this with the Sentinel for SAP solution. Then we can trigger a logic app, which then can lock a user, for example, in the SAP system. Now, obviously, we need to find out what are the function modules or what are the BAPIs to lock this user. And if you don't know that, then, well, just ask ChatGPT, or in this case, GPT 3.5. And if I ask here which BAPI can be used to lock users in the SAP system, I get here the BAPI result, BAPI lock user. That's the one. And obviously now I could ask also, can you tell me the required properties? And then hopefully, I get all the properties for the specific BAPI. So it really helps you also in these scenarios. And obviously there are lots of more cool scenarios that we can do. And maybe in the next episodes, we'll just take a look at one of these prompts regularly and hopefully inspire some of you to also check out Azure OpenAI or ChatGPT in the SAP context. So with this, quite a lot of news, but now maybe let's, or not maybe, but let's hand over to Ralitza. Maybe Ralitza, you can quickly introduce yourself, and then I'm looking forward to your presentation.
Yeah, of course. So first of all, thank you for having me today here on the channel to talk about high availability for SAP on Azure. My name is Ralitza Deltcheva, and I'm principal architect on the SAP engineering team at Microsoft. And in my work, I focus on reference architectures which are dedicated to high availability for SAP and disaster recovery as well. So let me quickly, I prepared some slides for today. So let me share, give me just a moment.
Perfect, yes.
Okay, so we did the intro already. So as you mentioned earlier, Holger, when we think about high availability for SAP in general, it's all about protecting the single points of failure in the system. And in an SAP system, there are several points which need to be protected with HA constructs. If we start first at the application layer, of course, you have the SAP central services that need to be protected. And there is another important component, the so-called SAP shared directories. And in order to have a resilient and highly available SAP system, these shared directories also need to be protected with some sort of a HA construct. And of course, you have the database layer. We all know that the SAP application is a three-tier application. So at the application layer and at the DB layer, you have these points that must be protected. Now, when I talk about high availability for SAP, I like to cut through the stack, so to go through the stack. And if we start with the application layer for SAP, we have been on a journey the last several years to transition to reference architectures for high availability, which focus on simplifying the architecture, optimizing from a cost perspective, and to rely more and more on the built-in features. So what do I mean? As mentioned, in a high availability system, you want to protect the central services for SAP. And the way you do that is with some sort of a clustering technology. If we are in Linux, that usually means a pacemaker cluster. If we are in Windows environment, that means Windows cluster. So this is the common pattern between the different reference architectures. When it comes to the SAP shared directories, where we started some years ago with the first releases, was that in order to provide a resilient solution, a customer had to build their own NFS server, essentially. And I love this slide because it shows the transition over the last several years, because today they actually have, customers have multiple choices to deploy a resilient infrastructure for the SAP shared directories. We have two options. You have Azure files, either NFS or SMB, depending on the operating system the SAP system is running on, and you have Azure NetApp files. So very often,
basically, that's a great example of cloudification of different original infrastructure services, like file share, as an example. So meaning it is really no management, it's a cloud service. They don't have to manage it, patch it, they just have to use it. We are guaranteeing SLA, that's it.
Exactly.
Right. Yeah. So,
exactly.
And it's interesting to see those pieces, how slowly some pieces are becoming a cloud service. I mean, SAP is a client server. I mean, still a software. But here it's really nice that see really some blocks are becoming a cloud service, which makes everything simple and more easier to manage, and generally speaking, even cheaper, not just from what they pay, but they need to operate as well. Yeah,
exactly. So we have two first party. I mean, if we talk about Linux first, right? So we have two third-party offerings that customers can use today to deploy the SAP shared directories. And that was an excellent segue to this slide, actually, because if we compare that to the NFS cluster, where everything is custom, essentially, and everything is on the customer to build, to maintain, to operate, to patch, that's not the case with NFS on Azure Files or NFS on ANF. I mean, you deploy within minutes. There is nothing to patch after that. There is nothing to operate. So it's much, much simpler construct to use in the reference architecture. Now, in the context of high availability, two topics which come up immediately are what about resiliency of the service, and what about cross-zonal replication? Mm-hmm. And then in the context of disaster recovery, then the question is, what about cross-regional replication? And you can see on the slide that, you know, both services have options, for instance, for cross-zonal replication as it is today. But I want to spend a moment to talk about the differences. For in-zone redundancy, I mean, they're both, I would say, equally protected. I mean, you have 3 copies with Azure Files. NFS on ANF also has a built-in resilience within the zone. There is a difference when it comes to the cross-zonal replication. So with NFS on Azure Files, you have synchronous replication across zones. So in the context of an SAP system, right? So imagine that you have your SAP MNT directory deployed on one of these first-party services. And if you have, for instance, your batch job logs stored on the file system, with NFS on Azure Files ZRS, you have this synchronous replication of your job logs across the 3 zones. Means if you have to fail over to another zone, you get immediately the same replica of the job logs in the other zone. With ANF, with NFS on ANF, that works a little bit differently. So in preview currently, there is an option to do cross-zonal replication, but it's a discrete replication. It's based on snapshots. So every so many minutes, you get a snapshot replication from one zone to another. So when designing for HA for the SAP central services, just keep that in mind, because if you deploy your compute across availability zones, and if you use that as a pure HA construct, failing over to the other zone will not give you exactly the same parity at the storage level. For cross-regional replication with ANF, you have SnapMirror. That's essentially the same, based on the same technology, which does the cross-zonal replication. And for NFS on Azure Files, for now, you would rely on scripts to replicate. So on Linux, a very typical solution is to use rsync, for instance. I also want to mention here another preview feature for ANF. So it used to be that the entry point for the ANF capacity pool is 4 terabytes. And currently in preview is a new bar. So you can start as low as 2 terabyte capacity pool. And the preview really applies to the deployment of the feature. Once the capacity pool and the volumes are deployed, I mean, they're subjected essentially to the same production SLAs and agreements as a 4 terabyte pool and the volumes deployed in it. So that helps with some customers with a smaller SAP real estate, as it is bringing the bar for using ANF lower. I mean, it's 50% lower essentially today. So if we stay in the area of the SAP application layer on Linux, I want to talk about a new reference architecture, a new configuration, which is available since last year, and actually it's highly recommended for any new deployments on SLES 15 and above. It's the so-called simple mount reference architecture or simple mount structure. And The motivation to release this reference architecture was the following. When you have a pacemaker cluster for the SAP Central Services, with the classic reference architecture, the file systems were managed by the cluster. That means that the cluster was responsible for remounting the file systems for ASCS and ERS. It was responsible for monitoring. And that introduces some jitter, so to speak. What I mean by that is, for instance, if you have like a temporary glitch with the file system, and that leads to exceeding the timeout, the configured timeout in the cluster, that could lead to failovers or restart of the SAP instance, depending on the SAP architecture, whether it's NSA1 or NSA2. With the new reference architecture, the big difference is that the file systems are not managed by the cluster anymore. So you mount your file systems via etc fs tab, and in the cluster configuration, you have a new resource in addition to the SAP instance, the SAP Start SRV resource. There are two new services, SAP Ping and SAP Pong, some creative naming here for the services from the colleagues at SUSE. But the job of these services is to make sure that at VM reboot, the SAP Start SRV daemon is not started, and it allows the management of the service and the instance to be done by the cluster. So it leads to a more resilient configuration. I would say also a simpler configuration, and again, very highly recommended for any new deployments on /15 and above.
Any chance to see this on Red Hat as well?
I have not heard from Red Hat that they have plans to implement a similar reference architecture, at least not yet. But what is very true is, I mean, it's a very competitive world. So, you know,
might see that we will see it.
Might see it in the future. Yes, we might see it in the future, but nothing concrete just yet.
All right.
Ralitza, you mentioned several times this is all the time for new configuration. Is there any chance to apply that to existing configuration, or is it simply too complex?
No, it's not too complex, and it is absolutely possible to apply it to existing deployments as long as they're on /15 or above. There is no requirement to do that, but it is possible, and it's not too complicated. I mean, essentially, it boils down to installing these additional services and reshuffling the pacemaker configuration. So it is possible, not complicated, and good idea also for existing installations, but not required. So the classic reference architecture is still supported. So if we switch our attention now to HA for the SAP application layer on Windows. You can see here I have tried to organize all the possible reference architectures that we support on Windows. We have a quite comprehensive portfolio. On Windows, when you install an SAP system, you have two options, right? To install with a shared disk, and to install with an SMB share. For the installation with shared disk, there are two options. I mean, the very first one we released many years ago is based on SIOS. It's a third-party product, and you can still do that. Just be aware that there will be, excuse me, additional licensing fees. The newer one is based on Azure shared disk, so native Azure shared disk. It allows you to do a cross-zonal replication if you deploy with Azure Shared Disk ZRS. There is some nominal charge for each VM that you are connecting to the disk, but in general, it's simple to execute. It's a good solution if you choose to deploy SAP with shared disk. On the other side, if you deploy with SMB share, I mean, the equivalent of what we discussed in the Linux world to build your own resilient file server is essentially SMB with SOFs. I mean, everything we discussed on Linux is applicable here. You're responsible for operating this SOFs cluster. So the feedback from customers on both Windows and Linux has been, we want something simpler. We want something where we don't need to patch it, maintain it, and so forth. So you have, in a similar fashion here, the two first-party services, right? So you can deploy with SMB on Azure Files, or you can deploy with SMB on ANF. In terms of cross-zonal replication, everything we discussed is applicable here as well. And for cross-regional replication, I just want to point out that with SMB on Azure Files, you also have the option to do AZ copy. So you don't have to do robocopy, which is usually the equivalent of rsync in Linux.
So Ralitza, running this on Windows or running this on Linux? I mean, if I ask Goran, the answer is very clear what he would prefer. But what do you prefer, or what do you see with customers? Because what do you prefer?
Well, I actually answered this question the following way. So choosing a distro or choosing an operating system is almost like a religious war. And from my perspective, what is important is that we support the different choices that customers make. Yeah. And we have portfolio across Linux distros. We have a very nice portfolio on Windows. So no matter what customers choose to do, we can support them.
Main thing is Azure, right? As long as
it's Azure, exactly. That's a very important point. So now let's talk about some updates. And in this case, the updates are about deployments with ANF. So for NFS and ANF, I just want to point out that we released a more resilient pacemaker configuration for the SAP Central Services. When working with ANF, NFS v4.1 volumes. As you know, on ANF, you can use NFS v3 or NFS v4.1. So for customers who are using this deployment construct, it's definitely a good idea to go check our articles and make sure that their configuration is up to date with what we have updated. And then for working with SMB on ANF, there is another very nice development. It used to be that in order to install a brand new SAP system with SWPM, the user under which context SWPM was running had to have domain admin rights. And that's not a very typical situation in the real world. Usually it's a basis admin who installs the system, and it's very rare for a basis admin to get domain rights. So that's no longer the case. There is a new feature that's available since last year. So you can go into your ANF configuration in the Active Directory connection, and you can specify there in the configuration the user which will run SWPM as a privileged administrator's privileged user. And once you do that configuration, you will be able to use SWPM without running into a problem, and you don't need to have domain admin rights. So for those customers who are using SMB on ANF on Windows, very nice gain here, very nice feature. So now if we shift our attention to the database layer, I mean, one of the more popular or most popular databases is HANA. With HANA, as you know, you can deploy in a HANA scale-up configuration, or you can deploy in a scale-out configuration. No matter what the choice is, we have, again, very comprehensive portfolio covering both scenarios, on/SLES and on RHEL. Now, I want to talk for a moment about the differences between these two reference architectures. So when you have a deployment for HANA Scale Up, and the file systems are NFS-mounted file systems, you have the following situation. The resource agents in the pacemaker cluster, the HANA resource agents, in order for them to monitor the HANA application, they rely on executables which are on HANA shared. And HANA shared would be NFS mounted in this case. If for some unforeseen reason there is a problem with accessibility to the NFS file system, the cluster loses its capability to monitor HANA. And without this additional configuration here, with this additional pacemaker configuration settings, what that means is that the cluster will not be able to quickly detect that the application, HANA in this case, for instance, went down. With the additional configuration, it introduces a monitor for the NFS mounted file systems. So it is capable to detect that the NFS mounted file system, HANA shared in this case, is not accessible anymore, and it can trigger a failover for the application to the other healthy side of the cluster. For HANA scale out, there are two different, actually, if we stay here for a moment, there are two different constructs, right? So you can do HANA scale out with standby node. It's also known as N+M reference architecture, or you can do a full-blown HANA scale out with the pacemaker cluster and replication to a secondary site. Now, when customers deploy HANA scale out, inevitably they're facing the choice, which reference architecture should I choose for my deployment? And it really boils down to three things. How important is the recovery time at application level? The cost, of course, I mean, nobody has unlimited budget, and complexity. And I mean, if we leave for a moment aside the first option, which is pretty much relying on Azure healing, which means relying on a virtual machine to be restarted, if we compare the HANA scale out with standby and HSR and pacemaker, in terms of recovery time for the application, with the N+M reference architecture, you have the element of data needed to be reloaded in memory. And with large systems, that can be a significant time. With the HSR with pacemaker, the failover time is quicker. I mean, pretty much the downtime could be equal to what it takes the cluster to fail over to the secondary site. And there is a configuration which can be done so that HANA has preloaded the data in memory on the secondary site, so you don't have to wait for the data to be loaded in the system. So that gives you the fastest recovery time from an application perspective. Now, in terms of cost, I would say this is also the costliest option because you have to duplicate the infrastructure on both sides. And it's also the higher complexity. So with N+M, it's HANA that's managing the failover or the healing, so to speak. With HSR and pacemaker, you have the additional layer of pacemaker cluster configuration. So yes, it is higher complexity. Now, as we are on the topic of high availability for HANA, I want to talk about an update that we released, which speeds up the healing time in some scenarios. So imagine the following situation. You have your HANA scale up in high availability configuration, and everything is okay with the virtual machine. So it's not a problem at the virtual machine level. But for whatever reason, your index server crashes. So in a traditional setup, without this additional hook configuration, what HANA is going to attempt to do, it will attempt to self-heal. And what that means is that it will try to restart the index server on the same cluster node. And we just talked about how in large systems, loading the data can take a lot of time. So you would incur this penalty with HANA trying to self-heal on the same cluster node. Since there is no status change which is signaled to the cluster cannot react, so it cannot trigger a failover.
Mm-hmm.
Now, the difference with this new hook is that it's tighter integration with the pacemaker cluster. So this hook can recognize when there is an index server status change. And it can communicate the status change to the resource agent in the pacemaker cluster. And as a result, the cluster can take action. The action is configurable in global INI. And it could be a fence action, for instance, which means that the virtual machine will be fenced. Or it could be a kill action, which will abruptly kill the HANA system on the site which is having troubles. In both cases, what's going to happen is that it's going to trigger a failover to the secondary site. And if data is configured for a preload on the secondary side, it actually leads to faster healing time for the application. So very highly recommended for customers to take a look at this configuration and implement if it is not already implemented, because it can help to really heal faster the application. Now, we're staying in the realm of pacemaker again, so Linux. And as you know, there are two possibilities on Azure to configure fencing device. And two possibilities on SLES, on RHEL, actually, it's only Azure Fence Agent. So we're talking here about Azure Fence Agent. With the traditional configuration for Azure Fence Agent, it was necessary to specify a client secret in the configuration of the pacemaker cluster resource. And with the heightened security which surrounds SAP systems, that presented a challenge for some customers who had very strict security and compliance requirements. So enter MSI. With Azure Fence Agent configuration with MSI, there is no client secret in the configuration anymore. So the security challenges would be solved. Now, it also has another very nice, I would say, side benefit. With client secrets, as it is currently, they have to be rotated every 24 hours, 24 months, I'm sorry. And this is the maximum that you can do. And this rotation, I mean, while it's not super complicated, it's still an additional overhead for customers to do, and it introduces operational challenges, essentially. With MSI, you don't have to do this rotation anymore. So for these two reasons, again, very highly recommended. If you are using Azure Fence Agent as a fencing device, switch to MSI. And the configuration change is not super complicated. And we have released a blog on how to switch. So especially if you are approaching the rotation time for your client secret, it would be a perfect opportunity to switch to MSI.
Yeah, one question here. As you mentioned, on Red Hat is always Azure Fence Agent. On SUSE, there are multiple versions. Azure Fence Agent came later, and we had prior to this for the SBD device. Could be either the iSCSI device, or later came also Azure Shared Disk as an interesting option. So basically, we have three possibilities here. When somebody asks you for the fencing, what would you suggest?
Well, so I mean, on RHEL,
on SUSE,
there is no choice. On SUSE, it really depends on what the customer prefers. With Azure Fence Agent, there is no additional infrastructure to deploy, so to speak. With the SBD devices, with the two options, if you choose to do a VM mounted over iSCSI, it can be shared across multiple clusters. So yes, you have an additional virtual machine, but since it can be shared with many clusters, the cost essentially is shared across all these clusters.
Yeah.
You have a bit of an overhead with patching the SBD devices. And by the way, for SBD devices, the most resilient configuration when you work with ASCS is to have 3 virtual machines,
Yes,
like
yeah.
one in each availability zone. With SBD based on Azure Shared Disk, you don't share. I mean, you do that once per cluster, but the benefit for this configuration is that there is nothing to patch really. I mean, you're not patching the disk. So these are pretty much the decision points one has to go through.
But if I would add here a DR as an example, as an additional one, somehow I would tend more to the Azure Fence Agent.
Actually, we have blocks, and I'll talk about that later. So both configurations are covered on how to do disaster recovery, and both are options really. So it's not that with SBDs you can't do a DR. I would say from a complexity perspective, it's probably about on par. And we have blocks which describe both failover procedures on the tech community blog site. So now the next area of updates has to do with cost efficiencies. I mean, these days with the current economic climate, that's a topic which comes up more and more. And we have released, excuse me, 2 reference architectures which help to cut down on the cost and to cut down on the number of virtual machines that one would require to operate an SAP system in Azure. The first reference architecture has to do with installing additional PaaS and IaaS instance on the cluster which is taking care of HA for your SAP central services. So you go through the configuration for central services, and then you can layer on top, adding 2 more instances. So PaaS and IaaS instance, it's supported for both ENSA 1 and ENSA 2. And in the cluster, in the Pacemaker cluster, there are constraints which keep the 2 instances apart, so one on each cluster node, as long as both cluster nodes are up and running. So the benefit is that in a smaller system, essentially you can get by with just 2 virtual machines for your SAP application layer. And by the way, I should mention here that we support the same configuration also on Windows. So it is possible to achieve the same configuration if you're running SAP on Windows. The second reference architecture again aims to reduce the number of virtual machines that are needed, but it achieves that in a little bit of a different way. So with this configuration, you run in a single Pacemaker cluster, both your central services and HANA scale-up. So instead of having to configure 2 Pacemaker clusters on 4 virtual machines, you can achieve that within 2 virtual machines. And you do need to have extra VMs to run your dialog instances. This is done to manage the complexity, of course. I mean, you don't want to pile up too much on 2 virtual machines as well. And I should mention here on the previous reference architecture that since now you're running also dialog instances on the cluster, that means that the virtual machines should be properly sized. I mean, they should be sized in such a way that they can handle the load which comes from an application SAP instance. Also here supported for ENSA 1 and ENSA 2, and this is only supported with HANA scale-up. So it's not really a scenario with HANA scale-out. And
some customer would ask you, can I move those 2 app servers from right to the left in the
Yeah, I mean,
so
that's
2 nodes
why.
for everything, in theory.
Yeah, I mean, in theory you could, but we also need to think about how complex it becomes, right? And how much you can run on 2 virtual machines and not run into operational problems. So for that reason, we're only supporting it in the configuration where the PaaS are running on separate machines.
I mean, basically, AS is a small processor, so adding to the HANA, okay, it's generally not a big deal, so to say, from sizing, for example.
Yes, ASCS and ERS are rather lightweight services. So,
but it's challenging. You know, I understand why we have this option to minimize the cost, of course. But I mean, as you mentioned already, you know, putting application server to get on top of it, a customer must understand that it's very complex to debug later to discover what is the problem, because if you have some CPU utilization, this is probably going from application server, because you have something, you know, select everything from universe somewhere, and it can be tricky. So the customer need to be careful how to approach to this solution. Because I mean, you have more flexibility. I like to have, you know, application server out because they're anyhow redundant, because you have much more control. But okay, if customer want to save money, this is a way to go.
Yeah, I mean, just to be clear, for this reference architecture, we do not recommend to add the app server on top of the cluster, which already runs HANA Scale Up and the central services. I mean, for exactly the reasons that you highlighted. I mean, we don't want to make things too complex.
Yeah, but you know, when customers see one option, they think, okay, another option is also probably supported.
Right. So it was a good question to clarify that. Yes, exactly. And last but not least, we talked a lot about high availability, but it's a good opportunity to share that now we have disaster recovery guides on learn.microsoft.com. It describes the concepts and the guidelines for designing disaster recovery for SAP on Azure. And in addition to that, so Goran, you were asking about DR procedures with the different fencing options on Linux, for instance. So they're both covered. These are blogs on the SAP Tech Community blog site, which describe in quite a bit of a detail how to do the failovers. And they're both based on ASR. To open up a bracket here, ASR or Azure Site Recovery has been very popular feature to design for disaster recovery for SAP on Azure. Why? Because when customers design for DR, another topic which comes up very quickly is the topic of cost. So you want to have the insurance, right? That should something really bad happen in one region, you have the option to stand up your workload in another region, but at the same time, customers are watching for the cost that introduces, and ASR is a good answer to that because you get the VM replicated. So whatever you do on the source side gets replicated on the DR side, and you're not paying for the cost of the VM in the DR side until you need it.
Do you?
Yeah, go ahead.
Do you see a lot of demands to implement HA plus some kind of DR in Azure, and especially how you would compare to the before the Azure on the on-premises environment?
Well, for customers who run critical SAP systems, usually, yes, in addition to HA, they want to have a DR configuration. Of course, when you're designing for DR configuration, it's not one size fits all, right? Yeah. So it depends on what the business requirements are, what is the RTO, what is the RPO. But the trends are, in general, that they want to keep the cost under control, and they want simpler patterns. Yeah. They want simpler procedures to perform DR.
Yeah, I mean, on the on-premises, customers were doing those DR, but I would say much less, simply because of the cost, meaning you do need another data center. I mean, that's already a hard thing. And here, okay, you just pin out, you have an ASR with some minimum cost, at least for the app layer, as an example, right? So probably these kind of stuff also are driving. I see more and more customer really who maybe didn't do DR on the on-premises are doing in the Azure the DRs, or extending to the DR as well.
It is definitely a popular area, and that's why we're investing more and more into documenting DR patterns and concepts and procedures. Yep. So that's what I had for today. Sorry, did you have a question?
No, I just wanted to add one thing, and that is about the documentation. I really have to say, if you go to learn.microsoft.com and browse through to the SAP section, I'm really impressed in the amount and quality of content that we have put there in the meantime. So I still remember, I don't know, a few years back, it was fairly scarce. There was some documentation, but now it's really amazing what kind of documentation is there in the meantime. And I mean, yeah, you have here a few links to the documentation. You also pointed out the different blog posts that we have on the SAP Tech community, but really, I mean, if you haven't checked out the learn.microsoft.com section, I think that's just amazing what you and the team have put there, really documenting all these scenarios. That's really fantastic.
And additional to that, we already covered this disaster recovery documentation already together with Dennis before few I think probably 1 month or so.
Yep. So well, that's it for today from me. And again, thank you for the opportunity to talk about HA and DR.
Oh, great.
No, perfect. Thank you very much, Ralitza. And as you said, that's it for today. But we'll have you again with some new updates in the future, and I'm really looking forward to that already.
Yep. Thank you.
Great. Thank you, everyone. See you next week again.
Thank you. Bye-bye.